So exact same idea. We give a formula for f. Turns out the formula for f contains an integral. They say find f prime, which means they want the derivative of f. So all you have to do is write it down. F prime of x. As we talked last time, the rule says you simply identify the integrand. This is how you find the derivative of an integral. And you take whatever input variable is in the integrand, replace that input variable with the upper limit. And then you multiply by d over dx. Dx because this is the derivative of f of x. Plug in the upper limit like so. And we're going to do something else, but we'll just pause there. Question? Same rule we used last time. Now you just repeat the process with the lower limit. Again, making sure that it's easy to get mixed up and think this should be dt, but it's not dt because the variable we're dealing with is x. So, any questions? So everything cleans up really quickly, and we're done. We just circle the answer. So. Question. Cool, next one. We haven't looked at limits since about September, really. Well, probably there was a limit. Test 3 probably had a couple of limit questions. So, first thing you need to remember is this limit flashcard. Trying to find a limit. We look to see if x is approaching infinity. And in this case, x is not approaching infinity. So we're going to skip step 1. We go to step 2. We try to see if it is possible to factor and divide. Notice it doesn't help to factor alone. It only helps if you can both factor and divide. So in this case, because the only factor of the denominator is h, unless we can factor an h from the numerator, it's not going to help to factor. So there's no reason to try and factor because you're not going to be able to factor an h from the numerator. Questions? Okay. Next thing you do is you simply try to evaluate the limit. That means you've got to think of h as being both slightly more than 0. You have to think of h as being slightly less than 0. So you just plug it in. You think if this is going to be like a little bit more than 0 or a little less, what will this be very close to equaling? Feel free to talk to each other, raise your hand and tell me. If h is really, really close to 0, like a little bit more or a little bit less, what's the numerator going to be very, very close to equaling? Looking for hands? There we go. Let's go, Emmy. So the numerator is going to get very, very close to 0. A little more or a little less. So it's not exactly that it's close. How many knew it? 2 points, 3 for Emmy. The bottom obviously is going to get very, very close to 0. But here's the really big idea. The bottom is just going to be very close to 0. It's very predictable because there's no computation on the bottom. But on the top, there's no way for you to compute how close to 0 you are. You might have this situation. The top is close to 0. The bottom is also close to 0. both of those decimals are close to 0. But they're 100, the top is 100 times bigger than the bottom. So that's 100. That's not close to 0 at all. So when you get close to 0 divided by close to 0, be careful to never think that's 1. You don't know what it is. We want to talk more about that. Okay. Prior to today, if we were trying to solve a limit and we ended up with close to 0 divided by close to 0, that was usually an indication that we had forgotten step 2. We'd forgotten to factor and divide. Today we learned a new rule called L'Hopital's rule. It's named after a French mathematician, L'Hopital. Okay. He discovered that if you encounter this situation where you're trying to solve a limit and you end up with either 0 over 0 or you end up with infinity divided by infinity, and these can be positive or negative, it doesn't matter. He came up with a way to solve the limit problem that we're going to talk about today. So the first thing you need to put in your notes and memorize is make sure you've got the limit flashcard memorized, because you do not always use L'Hopital's rule. We're only going to use L'Hopital's rule when everything else doesn't work. So make sure you've got the first 3 items of the limit flashcard, re-documented in your notes so you don't forget that. Give a second to make sure you have that written down. Or if you've already got a flashcard, then that's great. Just make sure you're reminding yourself of it. Watching pencils, make sure I don't go too fast. Okay, so we've got to this point where we're not really sure how to proceed, because as we try to find the limit, we're getting close to 0 divided by close to 0. But as I said over here, we don't have any idea what that really is. So what L'Hopital discovered was, can I erase this now? Okay. What L'Hopital discovered was if you end up with that situation, you try to find a limit, and you encounter the fact that your limit is either 0 over 0 or close to 0 over close to 0, or some combination of infinity divided by infinity, he discovered that you can create a new limit problem that will give the same result as the original limit problem, but it will be easier to solve. So what he discovered was you look at this problem as being a numerator divided by a denominator. You think of the top as being f. So our top is 8, parenthesis 1/2 plus h, to the 8th power, minus 8 times 1/2 to the 8th power. That's our numerator. We're going to take the derivative of that. We're going to find f prime. And you don't have to write this on your paper. I'm just writing it as I explain. You would have to write f prime equals. Well, it would depend on FRQ. On FRQ, you might have to write both. Multiple choice, it doesn't matter. So we need the derivative of this. Well, this part of the derivative is easy because there's no h in this term. Therefore, that derivative is 0. Here I have a multiplying constant 8. That gets multiplied by the 8 that you bring down using the power rule. Then you have the something, which is 1/2 plus h. And that's raised to the 7th power. And you have the d over, now I messed up here, this should be dh of the something. Because really we don't have an f of x, we have an f of h. Okay, questions, anything? Anybody need to repeat anything, say it again differently? Just summarize, oh yeah, please, John. David, sorry.
Could you then like split out the d1/2 plus h over dh and go even further?
Yeah, you need to keep going because now you've got the derivative of 1/2 plus the derivative of h. So the derivative of the 1/2, David, would be what?
0.
0. Then you would have dh plus dh over dh, which would be 1. So this is actually 1. Hence, we know that f prime of h is 64, parenthesis, 1/2 plus h to the 7th power. Is that what you noticed? Yeah. Perfect. Anybody else? 3 points for David. Okay, so summarizing again, it's just a limit problem. So you go through the limit flashcard first, but you get to the spot where you identify that the limit you are trying to find, right here, the limit you are seeking is the limit of an f divided by a g. And you find the limit to be what's known as indeterminate, like it cannot be determined. So L'Hopital says, let's do this limit instead. Let's go find the limit of the derivative of the top and the bottom. Because he discovered that the limits will be the same. The limit you are looking for is this, green one right here. But he discovered that the value of the blue limit will be identical. Now the limits only match if your first attempt at finding the limit results in this, one of these two indeterminate forms. Otherwise, L'Hopital's rule doesn't work, so you can't use it all the time. So, questions? Please.
So this rule can only be applied if your limit is a fraction, right? Because you have to have something to divide.
Yes, take it for that one. Yeah, L'Hopital's rule only works if you can see the limit that you are solving for as being an f divided by g. Because he said, you're going to take the derivative of f, you're going to take the derivative of g, find a new limit, and the two limits will be identical. So now we look at g, and also notice it is important again to make sure you're identifying whether this is dx or dt or dh. In a limit problem, it's always whatever the limit is whatever the limit is respect to. So now we need to find g prime of h. So g of h is just h. So raise your hand, please. I'll pay. What would we write down for g prime of h? Yes? Don't overthink it. Just want to get you thinking with me, not just watching. Cambria? Close. So here's our g of h. We want to take the d of that, and it's over dh because h is the input variable in this problem. So it turns out to be 1. How many knew it? Points 3 for Cambria. Please, go ahead.
So, do we not do anything with the minus 8 times 1/2 of the 8?
Say it one more time.
So we don't do anything or take the derivative of the second term on the numerator?
Gotcha. I'll get you to see it, then it'll stay in your head better. So I've got f of h. I've got to take the derivative of this. But as you just said, I'm taking the derivative of two terms. It means I can consider the derivative separately. The second term is only a constant. So the derivative of any constant is 0. So I did consider it, I just realized it was going to be just minus 0. Does that make sense? Yeah. 2 more. Yeah. Please, Jack.
How did you get the 8 times 8 when you were calculating?
Here.
Yeah.
So let me write one that's kind of more what you're used to seeing. So you're used to seeing stuff like this, where we'll take the derivative of, I don't know, this was way back in October. Like that. And we would say, oh, the 4 is a multiplying constant, so just write it down. Then we got to bring down the 3.
Can we go back to that?
The new power is 2. And then you have dDx of the x plus 5. I don't know if that helped. Does that answer your question?
Yeah.
3 points. There you go. Okay, so now what happens is you create a brand new limit problem. You say, I'm trying to find the limit as h approaches 0 of my f prime divided by my g prime. Oh, these are h, sorry. Here's my f prime. So this is the limit as h approaches 0 of 64, 1/2 plus h to the 7th. And my g prime was just 1. So that's the new limit problem I'm trying to solve. Because L'Hopital said, if I can find this limit, the value of that limit will be exactly the same as the value of this limit. Questions? So I just go through the process again. I am not approaching infinity, skip step 1. I cannot factor and divide, skip step 2. Step 3, plug in a value that is close to 0. So when h is getting close to 0, so h is either a little more than 0, or h is a little bit less than 0, I'm going to get, let's see, 1/2 plus close to 0, going to be close to 1/2. I got to use my fingers. 1/2 to the 7th. So 1/2 squared would be 1/4. Go again, that's 1/8, 1/16, 1/32. I'm really fast at this. 1/64, one more. 1/128. So my numerator is 64. So when h is getting really close to 0, that whole thing is getting very, very close to 1/2 because the bottom is just 1. If you need me to repeat anything or talk about anything, questions, anything, please.
Is there any way that you'd have to use the L'Hopital rule twice?
So, for our class, I think I've seen one problem over the years where you did have to use L'Hopital's rule twice. There's actually no restriction on how many times you can use L'Hopital's rule. But for our class, I've rarely seen that it's required more than once. So, please.
At the very beginning of the problem, you found when 0 was a little above 0 or when it was a little below 0, but now you only found that when it was a little above 0.
Oh, 2 points. I just didn't, I should have spoken a bit more clearly. In my head, I was thinking, well, it doesn't really matter whether I'm plugging in a little more than 0 or a little less. 1/2 plus either of those is going to be really close to 1/2.
Okay.
So I really did consider both. 2 more. Please.
Is there a situation where it would matter if like between like the little more or a little less, like is there a problem with that would make a difference?
So whenever you're checking a limit and you're checking a little more or a little less, the places where it usually makes a difference is in a piecewise function where left and right grabs a different formula. Does that make sense?
Yeah.
Or in a non-piecewise function where when you check a little more and a little less and the result is close to zero, like we did the first time. When you get close to zero, then you just don't know where you're at. Here, we have something easy to compare to. 1/2 plus close to zero is really close to 1/2, whether we're a little more or a little less. So that's really all you're looking for. Does that answer your question? Two more. Anybody else? Cool, let's keep going. So number 9. So first thing, it's a limit problem. X is not approaching infinity. We don't have to worry about that. Factoring and dividing. You can't factor things out of an ln without using special ln rules, so that doesn't look very promising. So I try the left and right thing, meaning I try to see what's happening as h gets a little bit more or a little less than 0. But it always helps if you can think of numerator and denominator. So in this case, because of course we're practicing L'Hopital's rule, so kind of expect to use it. Raise your hand, please, if you could tell me what would be most appropriate to be my thought as far as what I would consider f to be in this case. Again, it's f of h. And then the bottom is going to be g of h. So raise your hand, please. I want everyone's hands. All can see it. What would I consider to be f, and what would I consider to be g? I've got to create a fraction somehow. There we go. Just wait a few more minutes. Minutes being the wrong word, a few more seconds. Let's go, Nelson.
The ln times 2 plus h.
So I can't, this is all inside the ln, so I've got to take all of it. So that's my f. Okay, how many saw it? 0.3 for Nelson. And then do you see the g, Nelson?
H ln of 2.
Can't really do that. What you have to think of is this as one thing, because you can't separate the stuff that's in the ln. And then that's all being multiplied by 1 over h. Multiplying by 1 over h is the same thing as dividing by h.
Got it.
How many saw it? 2.3 for Nelson. Question. So now back to what Zarin said, think about what's happening. Raise your hand if you can tell me. As h gets a little, h is a little more than 0 or a little less, what's going to happen to f here? When h is a little more than 0 or a little less than 0, what will be the value of f? Hands up. Good work thinking with me, not just watching. Paul? As h gets really close to 0, in either case, this is going to become very, very close to ln of 1. But the natural log of 1 is exactly 0. So we're encountering the same situation as the last problem, where the numerator is getting very close to 0 as h gets close to 0. Okay, show me your hands if you knew it. 2 points, 2 for Paul. I want to talk about it more, get another explanation, anything. Cool. The bottom, obviously, as h gets close to 0, is close to 0. So we have a L'Hopital's rule situation, because the limit we tried to find resulted in 0 divided by 0. Question. Cool, so now we just go to work. We need to find f prime, we need to find g prime. G prime, extremely easy because it's just h. So it's going to be dH over dH, which is 1. To find the limit of f, you have to remember the ln rule. So, let's see. We've got to take d over dh of natural log 2 plus h over 2. I heard some people saying that the derivative of the ln of something is 1 over that something multiplied by the derivative of that something. Okay, I'd like you to raise your hand and explain this one. When I did dDH of this something, I wrote the something in a different way. Raise your hand if you understand what I did. Like you can see why I changed this something into this. I just prefer to avoid division. Brindley?
It's just like, it's dividing by 2 the whole thing, so you can factor it out.
No, it's perfect. Yeah, dividing by 2, multiplying by 1/2, no difference. But for me, finding the derivative, how many saw it? 2 points, 3 for Brindley. But for me, the derivative is easier now because that 1/2 is a multiplying constant. Also, notice this. Pull this out of the way. Okay, 1 divide, wrong button. So 1 divided by a fraction is the same thing as 1 multiplied by the reciprocal of the fraction. So this will become 2 over 2 plus h. That 1/2 is a multiplying constant, so it just comes out. The derivative of 2 plus h is 1. When these multiply, these divide, I'm finished with my derivative. So you need me to talk through that again. I just found my f prime of h is 1 over 2 plus h. Questions? Please.
When finding like a derivative of ln, can you split it up so then it's like ln 2 plus h minus ln and 2? And then take the derivative of both?
That would also work. That's very smart. That's very good, for sure. Because that's a property of ln's. That this we came across recently in a homework problem. Natural log of a divided by b is the natural log of a. Subtract the natural log of b. So it's not a calculus rule, but it doesn't matter. It's a rule. That's perfect. That's really good. Hold on a minute, though. I feel like I just contradicted myself. I know that would work. So, anybody else? Cool. So I have f prime, I have g prime. So I create a new limit problem. I need to find the limit as h approaches 0 of my f prime divided by my g prime. Once again, I use my limit flashcard. It is not a limit as x approaches infinity. Skip step 1. There's no factoring that can be done. Skip step 2. When I try to find the left and right limit, when I try to think of h as being a little more or a little less than 0, this limit's going to equal 1/2. Questions? Every single answer to every L'Hopital rule limit problem is 100%. Mark that down, put that in your notes, make a flashcard. So yeah, it's interesting. This problem was given in 1973. That one was 1969, I think. But yeah. Question? Sweet. Keep going. Okay, number 10. 10 is a limit problem again. The limit is not h approaching infinity, so we skip that. There's no way to factor. So we skip that, so now we just try to see what happens when h gets close to 0. Well, if h is a little more or a little less than 0, we're going to have an integral from 1 to 1. Okay, anytime you start and stop an integral in exactly the same place, the result will always be 0. Because you aren't doing anything. If I start and stop the integral at 1, I'm not doing anything, so the top's going to get close to 0. The bottom also gets close to 0. Hence, we again have a L'Hopital rule situation.
Cool.
You wouldn't need me to talk about it. Yeah, this worksheet's not very clever. It just has you keep practicing L'Hopital rules. So.
I'm just gonna guess half.
Dang! Must be this. 1/2 is not an answer.
Just make my own. It's
Zaren's writing on the test.
Yeah.
I always catch these trick questions. Oh boy.
Okay. So, we need to know, okay, this one's pretty clear. Here's the numerator. So we're going to create a new limit problem. Okay, now let's do the, no, it doesn't matter. So to take the derivative of an integral, simple. You simply grab the integrand, write it down. Some space here, hold on. So write down the integrand, but I take away the input variable and replace the input variable with the upper limit. And then I multiply by d over dh. Remember, it has to be dh because of this h. The dx is really just a temporary variable of the upper limit. Okay, and then we're going to subtract, but I'll pause there to see if anyone wants me to say anything again or differently. Questions or anything? Please, David.
Is this? I think I might have missed something. Is this just finding out what the integral means, or nothing is equal to? I guess.
What I'm doing. So the big problem here is to find a limit. And I definitely have the limit of an f divided by a g. Are you with me there?
Yes.
So it does appear that L'Hopital's rule could be a possibility. I tested to see if L'Hopital's rule would work and discovered it will, because, or at least it possibly might, because as h gets close to 0, I'm getting 0 divided by 0 as my limit.
How does the top? Oh, because it's 1 to 1.
Yes, that answers your question. 3 more. So now I'm working on finding my f prime. You would need me to explain that again. Minus, now look, you can save yourself a little time. The next part of the rule right here is going to be exactly the same as the first, except that instead of using the upper limit, we use the lower limit. But the lower limit is a constant. So this derivative is going to be 0, so this whole thing is going to be 0. Question? Please.
Can you just say that again?
So the rule for finding the derivative of an integral is symmetric. You identify the integrand, which is right here. So I identify the integrand, and then in place of the variable within the integrand, I place the upper limit. Good. Then it's multiplied by, so that's this part, multiplied by the derivative of that upper limit. So the dDH of the upper limit. Then it's minus the exact same thing with the lower limit. So I'll have the integrand, so if I were to write it out, this is what I'd have. I'd have the square root again. In place of the x, I would place the lower limit. That's this part. Then I have the derivative of that lower limit. But I don't really have to write all this out because I can see that this is going to become 0. 0 times whatever is just 0. Does that help?
Yeah.
2 points. There we go. So my f prime simplifies a lot. F prime of h is simply, because this again is 1, so f prime of h is square root 1 plus h to the 5th power plus 8. That's my f prime. My f prime of g is simply this. Here's g. So my g prime is just 1. Questions? Please, look.
So if we have the h like approaching positive 0, negative, like a little bit more than 0, a little bit less than 0 for f prime, do we like do that and solve for what that like expression is, or do we just leave it as the square root of 1 plus h positive?
Perfect. 1 second. Let me just get this lined up here. So, just kind of summarizing the whole situation. The goal was to find this limit right here. The limit of an f divided by a g. Good there? When we tried to do that, the result we obtained was indeterminate. We don't know. Good? So L'Hopital says, scrap that idea. Let's go find the limit of the derivative of f and the derivative of g. So that's what I'm going to do now with me. So, moving this out of the way, we take the limit of f prime divided by g prime, like that, as h approaches it. Was that your question, Logan?
Yeah, I just didn't know if we like figured out what that expression meant before we did the limit.
Okay. Somebody else had their hand up a minute ago, too.
Oh, yeah.
Jonathan.
You found the derivative of the integral, but what's the difference between doing that versus just finding the antiderivative equation?
Say it one more time, Jonathan.
What's the difference between finding the derivative of the integral using that rule you had above them versus just finding the antiderivative equation?
So, let me finish this and hold that question. We'll go back. Everybody else okay here? So then you simply think, okay, if h is going to get close to 0, let's have you think with me again now. Hands up. If h is a little more or a little less than 0, what's the numerator going to be very close to? Hands. Don't say 1/2. Okay. As h gets a little more or a little less than 0, Allison, what's the numerator going to be? So this is going to get very close to 0. So what's 1 plus close to 0? And that to the 5th power will be close to. So this is close to 1. Close to 1 plus 8 is close to. Square root of close to 9 is close to 3. Bottom just gets close to 1. How many knew it before we did it? 2 points, 2 for Allison. Question? Okay, Jonathan's question. We're trying to find the limit, so we ended up finding the derivative of this integral. Correct? Using the rule. It is mathematically feasible, not possible, to find the antiderivative of this first, plug into that antiderivative these two limits, subtract, like we've done previously, and then find the derivative so we can use L'Hopital's rule. But that's not a, you can't do it, I can't do it without digging out a textbook. Like, we don't have the tools based on what we've learned in this class to go that route. So you have to use this rule. There's no other way. Like, you could try, you just won't. Is that your question? 3 point? Yeah. See? Okay, number 11 is going to feel very much like, so I'm going to leave this one for you to work at home. Number 11 is going to feel very much like the first example we did today, or the first L'Hopital rule example, number 8. So look at your number 8 notes again and make sure you don't have any questions. Anything that you're like, wait a minute, I don't understand this, you want to make sure you get that in your notes so that when you work by yourself on problem 11, you don't get stuck. So, questions? Cool. Do number 12, go. Do number 12, please. Just stop me if you have a question. I'll help you one-on-one if you need. So show me what you got. So like this A, B, C, D, or E. Show me. Or this means I don't know. So A, B, C, D, E, I don't know. You can give yourself 2 points for voting. I'm using the rule for finding the derivative of an integral, which means I identify the integrand. So f prime, so f is the integral, therefore f prime is the derivative of the integral. I simply write down the integrand, but in place of the variable of the integrand, I plug in the upper limit. Anyone need me to explain that part of the rule here? Then I multiply by d over, look, the input variable is an x. So that means this has to be dx. I take the derivative of the upper limit and do the exact same thing with the lower limit. But that's equal to 0 because this is equal to 0. That's equal to 1. Hence, the derivative of the integral is just 1 over x. Show me your hands if that's what you got. 2 points. Questions? Cool. D number 13, go. Stop me if you have a question. Make sure here it should be x squared.
That will be 100 dx.
Okay, show me your vote again. A, B, C, D, or E. Show me. Show me your vote. A, B, C, D, E, or I don't know. Everyone give yourself 2 for voting. Well done. Everybody got that one.
Probably that's how it works in real life.
Question? If you need me to do it, just go like this. I'll be glad to do it. So, since capital F is the integral, capital F prime is the derivative of the integral. So, my input variable is x. So the rule says you identify the integrand, write it down, replace the variable of the integrand with the upper limit. Go like this if you need me to re-explain that. Then multiply by d over dx, because this is an x, of that upper limit. Questions? And exactly the same thing with the lower limit. But short, well, let's just write it out. So you go square root, 1 plus, lower limit is 1, So you have 1 over dx. Questions? But as is often the case, it's not always, be careful. This isn't always 0, but that is 0. So if this is 0, this is 2x. So f prime of x, capital F prime of x, 2x, square root, 1 plus. To cube something means multiplied by itself 3 times. So this becomes x to the 6th. Question? Cool. Keep going. I'll let you work on that one with L'Hopital's rule. Just don't forget that sine squared of theta means this. Like that. So, do that one at home. The notation here is different, but it's not a new problem. It just says find the derivative of an integral. So we talked about how to do that. That one's very straightforward. Notice, okay, all eyes on the board. Look up. Be careful. When it says find f prime of 2, you don't go plugging a 2 in. You've got to go find f prime of x first, always. So you go find f prime of x first. Once you have f prime of x, then you can plug a 2 into your formula for f prime. Questions? L'Hopital's rule again. This is just like number 8, except it's cosine instead of sine. Derivative of an integral. Do that one quick, go. 19. Okay, show me your vote, A, B, C, D, or E. Show me. Fist means I don't know. If you're doing this, give yourself 5 points. Questions? Wave if you need me to show it. Cool. Don't forget here, 23, you're going to have to use the product rule. So, since you're going to end up using L'Hopital's rule to solve the problem. Good work today, well done. Cool.